We're going to start off by talking about wind. Wind and currents can affect the UAS performance and maneuverability during all phases of flight. You have to be vigilant when operating the UAS at low altitudes or in confined areas, near buildings or other man-made structures, even mountains. Consider the following effects on performance. If you have an obstruction on the ground, and that would affect the wind flow, like around a building. Like if the wind's blowing on one side of a building and you walk around to the other, you really don't feel it. So the UAS will kind of be the same way. If you're flying on one side and there's no wind, but as soon as you cross over or go up a little bit higher, you'll start feeling that wind, and the UAS can react to that. And sometimes it can react to that in ways you don't want it to. High winds is a huge factor in a UAS. Remember the app that we've been talking about, UAS Forecast? You can set a wind speed on it. It goes back to if you're comfortable in flying. High winds, I definitely wouldn't recommend flying in. It's personal preference, and it's more so personal skill level on wind to me, like in flying in high winds. But best judgment, always comes into play with that. Alright, so let's go on to air mass and fronts. Air mass is in front when a body of air comes to rest on or moves slowly over an extensive area, having, fairly uniform properties in temperature and moisture. The air takes on three properties. The area over which the air mass acquires and identifies distribution of the temperature and moisture is its source region. And as the air mass moves from its source region, it tends to take on the properties of a new underlying surface. The trend toward the change is called air mass modification. When an air mass is different in such properties advance upon a dissimilar air mass, the division line is referred to as a front. So here we can see a weather symbol map to kind of show you the different forms and how it's labeled. We've got a cold front, warm front, stationary, occulted, a through, ridge, squall line, dry line, and a tropical wave. The physical manifestations of warm air or cold front can be different with each. Atmospheric stability is defined as the resistance of the atmosphere to vertical motion. A stable atmosphere resists any upward or downward movement. An unstable atmosphere allows an upward or downward disturbance to grow into a vertical current. Determining the stability of an atmosphere requires measuring the difference between the actual existing ambient temperature, lapse rate of a given parcel of air, and the dry lapse rate. Because UAS operates at low altitudes, it may seem as though lapse rate may not be a factor, but the stability of local air masses can have significant impact on ambient conditions. Unstable air can often result in weather conditions unfavorable for UAS operations. A stable layer of air would be associated with temperature inversion. That is a condition in which warm air is stimulated above cold air. Warming from below, on the other hand, would decrease the stability of air mass. On our graph up here would be characteristics of stable and unstable air. Visibility in clouds. So let's talk a little bit about this. Visibility from the control station of at least 3 statute miles. What we're talking about is visibility from where you're standing, where you're operating the drone at. You need of at least 3 statute miles of visibility. You need to operate 500 foot below and 2,000 feet horizontally from a cloud. Those standards must be maintained throughout the entire flight. You can get local weather reports or use a form of app on your phone. For example, let's say a nearby tower extends to 1,000 feet AGL. The clouds are above the top. Thus you know that even if you climb to the maximum altitude of 400 feet AGL, which you're allowed to fly, then you have more than the required 500 feet of separation from the clouds. When in doubt, always choose the most conservative and safest option, which is sometimes may delay the operation, but it is imperative that the UAV not to be operated above any cloud. Thunderstorms present many hazards while flying. They can produce sufficient water vapor, unstable lapse rate, and an initial lifting force. All of those are bad for flying a drone. The greatest hazard to an aircraft is called squall lines. They're non-frontal, narrow bands of thunderstorms often develop ahead of a cold front. Embedded thunderstorms are those that are obscured by massive cloud layers and cannot be seen. A pilot should always expect these hazards. Microbursts are small-scale, intense downdrafts, which, as they get near the ground, they spread outward from the center in all directions. They can reach a maximum speed as strong as 6,000 feet per minute, and exceeding the capabilities of your UAV. So let's talk about icing. Icing is a structural icing occurs on an aircraft whenever supercooled condensed droplets of water make contact with any part of the aircraft that is also at a temperature below freezing. So with icing, your lift will decrease, the weight and stalling speed for a fixed wing, and propellers. They could freeze. Your thrust decreases and your drag increases. The presence of ice pellets at the surface is evident that there is freezing rain at a higher altitude, while wet snow indicates that the temperature at your altitude is above freezing. Remote pilots should avoid flying in conditions that may produce icing. As it appears that icing is accumulating on the UAS, it should be recovered immediately to avoid loss. Flying in any type of bad weather is usually a bad idea. I try to stay away from it, and I recommend that you do too, unless you're in a situation where you have to. But always stay clear of icing. Always check your propellers. Everybody knows what fog is. Fog is a surface-based cloud. It's composed of either water droplets or ice crystals. Like in the mornings, you can look over the ridgeline, and usually it's covered in fog. There's different types of fog. There's radiation fog, and it's formed when the terrestrial rotations cools the ground, which cools the air. Advection fog formed when warm, moist air moves over the cooler ground or water. So, weather briefing. It's your job as a PIC to encourage and obtain weather information from flight services prior to any flight. You can get those at several different places. There's a website called www.1800wxbrief.com. You can create a free account. You can get those from, like the app we've been talking about, the UAS Forecast. They show up and it's extremely handy. But always get your information from a trusted source. The Automated Surface Observing System is a primary surface weather observing system in the U.S. Most airports have automated weather reporting systems. They're minute by minute and can be sent directly to the pilot. You can access this at www.aviationweather.gov. Surface aviation weather observations, a compilation of elements of the current weather at individual ground stations across the United States. The network is made up of government and privately contracted facilities that provide continuous up-to-date weather information. So let's break down a METAR real quick. And let's start with the station identifier. Usually a 4-letter code is established by an international civil aviation organization in the 48 states. A unique 3-letter identified by the letter K. For example, Gregg County Airport in Longview, Texas is identified by the letters KGGG, K being the country designation and GGG being the airport identifier. In other regions of the world, including Alaska and Hawaii, the first 2 letters of the 4-letter identifier indicate the region and country. Alaska identifiers always begin with the letters PA, and Hawaii identifiers always begin with the letters PH. So K always starts, especially where we're at, we need to focus on K would be your first, and then your three letters would be your airport identification. Right past that, we have a date and time report. It's depicted as a 6-digit group. The first 2 digits are the date, the last 4 are the time. And it's always given in Zulu time, as opposed to local time. A modifier denotes that a METAR came from an automated source, or that the report was corrected. If the notation auto is listed in the METAR, the report came from an automated source. So let's use an example that's close to home to try to help explain this a little bit better. Let's use Wendell H. Ford, the airport here in Hazard, Kentucky. The FAA identifier is CPF. So like we talked about, so K would be in front of that, so your airport would be KCPF. Terminal Aerodrome Forecast. It's an report established for the 5 statute mile radius around the airport. TAF reports are usually given for larger airports. With each TAF, they're valid for a 24 to 30 hour time period. A TAF is updated 4 times a day. The TAF uses the same description as abbreviations as METAR reports. TAFs only give a little bit more information.